welcome to next lecture on electrical machines 1, and we were discussing about armature reaction, and in our last lectures we qualitatively discussed what is the armature reaction, and then what are its bad effects, and also we discussed about how to get rid of these ill effects of armature reaction by using a compensating winding, and also along with interpole winding. And as I told you, this discussion was on qualitative basis, very simple to explain. Today, we will try to draw the field pattern in the air gap of the machine because of the stator field, which are projected poles, and the nature of the field is trapezoidal. And then we shall try also to draw the MMF distribution of the armature currents along the air gap of the machine. And this MMF will cause armature air gap. In the air gap also, this armature MMF will produce some armature flux. Therefore, resultant flux will be the sum of these two, and from that also whatever we got in our earlier qualitative discussion, we shall try to conclude those things once again, but this time really drawing the net air gap field in the machine. Now, before that you recall that this was my armature. I just want to point out one thing, and these are my projected poles. Field windings I will symbolically I will show by one turn, that is this is suppose south pole and this is suppose north pole, and lines of force will go there. So, this is symbolic representation of field coils, okay, sectional view. Okay. And here also these are the field coils, they will carry direct current called field current, and this will be also cross cross and dot dot, they are connected in series. So, and this is this thing. Now, I told you that a DC machine like its AC counterparts may be a multipolar machine, that is number of poles may be greater than 2. In this representation, mind you that if I know what is happening under a pair of poles, the remaining things will be repeating for the other pair of poles, same things will be repeated. This I told you on many occasions during AC machines as well as during DC machines also. Therefore, if we concentrate our attention what is happening under a pair of poles, then that will be a good thing to study, and then I can say same thing is happening in the other pair of poles as well. So, in this simplified diagram, no matter whether it is a multipolar machine or not, only 2 poles are shown and all angles here are in electrical degree. Okay. That is how it will be carried out, and this is your armature reaction, armature terminal, sorry. Okay. I will just copy this down because many times I have to sketch this. So, this is the thing, and then there are armature conductors. So, this is under a pair of pole, all angles are here in electrical degrees. Okay. And this is direct axis along this line, and this is the quadrature axis. Okay. Now, suppose it is operating as a generator, that is what I told you, then and the direction of rotation of the armature with the help of a prime mover is suppose clockwise, then these dots will be the direction of the EMF as well as current. This you must understand when the armature will be loaded. So, this side under north pole, this will be all cross, and this side under south pole, this will be dot. Now, in this one, when there is no armature current, that is the machine is not loaded, then of course, the field will be same as this field produced by the stator, and we know that this field will look like this one along the air gap of the machine. This field, as I told you, it will be trapezoidal in nature. Like this, and it continues. So, this is the south pole and this is the north pole, that is it is and this is the B, flux density distribution along the air gap of the machine, and mind you this angle is in electrical degree. Okay. So, this will be the B distribution when there is no armature current, that is I A equal to 0. Now, the moment this armature is allowed to carry some current to deliver power to a load, then the direction of the currents in case of generator mode will be same as the direction of the induced EMF. Therefore, these dots once again will represent the direction of the current, and cross will represent the direction of the current in the under the two poles as shown. Now, in our qualitative discussion, we told you that the direction of this armature field will be vertical like this, because this is cross, this is dot. So, current direction will be up. So, this is the armature MMF, it will act along in a line along the axis perpendicular to the direct axis, that is called quadrature axis. And this armature MMF, there will be no component which will demagnetize these poles. Had there been a component in opposition to the original field was like this, that is say let us call it MF and let us call it MA. MA I have written already. You can easily see this MF, there is no component of MA armature MMF which opposes this directly, but only thing it will distort this field such that the lines of force will be concentrated in this side and it will be radified this side. That is what I discussed, I am not repeating that. Therefore, lines of force will be concentrated on this side. Another thing is, this is the direction of rotation. Another term people use often, so far as the direction of rotation is concerned, every pole can be thought of, there are two pole tips, this is one pole tips, this is another pole tips. Suppose you are sitting on the armature and moving like this, you will first see these poles and after some time you will see this pole. So, that is why these poles are named as this pole is named as pole tip, leading pole tip, leading pole tip. And this pole tip is called trailing pole tip, trailing. So, armature is moving this way. Similarly, this one will be leading pole tip and this one will be trailing pole tip, because the moment you first see this north pole, you see this pole tip and then this one. So, like that. So, in case of generator mode of operation, the flux will be concentrated more towards the trailing half of the pole, because lines of force will be concentrated here and it will be radified here, such that the electromagnetic torque will be in the opposite direction. Therefore, in case of generator mode, remember lines of forces will be concentrated in the trailing pole hub. This hub can be called trailing pole hub, this is leading pole hub, concentrated under trailing pole hub. And it will be radified under leading pole hub, we know that. And electromagnetic torque will be always experienced from the denser concentration of lines of force towards the radified portion of the lines of forces. Therefore, electromagnetic torque will be in the opposite direction. These things we discussed. Therefore, it looks like the flux per pole will remain same, as I told you, because increase in one half will be perhaps compensated by the decrease in the other half, and so on, flux per pole remains same, and whatever formula we derived for the induced voltage really remains intact. But because of saturation, the increase in one half may not be will be slightly lesser than the decrease in the other half. Therefore, flux per pole decreases slightly, but nonetheless there is no reduction in the lines of in the value of flux per pole because of demagnetization component. Everything is concentrated, that is this is MF and this is MA. Therefore, MR will be somewhere here. So, lines of force will be concentrated this side, that is the whole idea. Anyway, this was the scenario. Now, today we will go a step forward, we will try to investigate really how this armature MMF will look like when it carries current. So, with brush position in the this point is worth mentioning with and another thing you just note down, this axis, the field axis, it is this one. Okay. Then there are two terms used, one is called G and P. Easy, geometric neutral plane, geometric neutral plane. So, this is GNP. No, this is not GNP. Geometric neutral plane will be this is d axis with I A is equal to 0, is along q axis geometric neutral plane is along q axis, that is perpendicular to field axis. By field axis I mean stator field axis. So, geometric neutral plane will be, this is the armature, this is your field axis. Geometric neutral plane is called this one, GNP. Clear? This is the field axis. So, GNP is a line perpendicular to this GNP, and there is another term called MNP, which is called magnetic neutral plane. Magnetic neutral plane. Sorry. Magnetic neutral plane is the plane where B will be 0, where no magnetic field exists. That is called magnetic neutral field. Now, let us consider a this same machine, let us consider here. In this machine, therefore, what is the geometric neutral plane? Geometric neutral plane is defined, this is your field axis perpendicular to, that is the q axis is your geometric neutral plane, q axis which coincides with geometric neutral plane. When I A is equal to 0, when I A, that is the machine is under no load condition, which one will be where, in which points here the field will be 0? Along this line only, because B distribution is like this. Can I go and copy this? Yeah. So, this is your, this is the B distribution. So, in this case, this is the line along which theta is measured, and what is d axis? D axis is middle of this 0, pi, 2 pi or 360 degree electrical. So, magnetic neutral axis with no armature current, if there is no armature current, no armature field. Therefore, where will be the flux 0? Here only at pi, that is q axis. So, this happens to be, it will coincide with GNP. So, when I A is equal to 0, conclusion is GNP and MNP coincide with I A equal to 0, mind you, that is fine. Now, there are conductors as I drew earlier, and once again let me keep a copy of this, it will be, otherwise I have to draw often. Acha. Now, here that is fine, GNP and MNP coincides when IA is equal to 0. But the point is, the moment the armature will carry current such that these are dots, and this side are cross. I can easily see there will be now a field here because of armature field. If I apply right hand rule, there will be some magnetic field here. The contribution of the main field will be 0, no doubt here, but because of armature current, when IA is not equal to 0, there will be some field existing along the q axis, or q axis is nothing but geometric neutral plane. Along that line there will exist some flux. Okay. And we want to find out where will be MNP, that is what I am telling. So, your resultant field is like this, armature field, cross field, then we will find out where that armature field is there. Now, so GNP and MNP you just keep in mind, we will be using that concept. Therefore, without any load on the armature, this is the field form along the air gap of the machine, and this is also the resultant field form. But when IA is not equal to 0, when IA that is the armature current is not equal to 0, that is we are passing currents, then this field will be there as well as field due to this current distribution will be there. Now, the question is what will be, how to sketch this field due to this current distribution. We have discussed it in case of electrical machine too, but I will quickly tell you how to find that out. It is like this. Suppose you have got say 3 conductors, 3 coils say. It was on the slots of the machine, I have used the developed diagram. Suppose this is coil 1 and its return is here 1 dashed, and it is carrying a cross dot current. Got the point? This is coil 2, its return is here 2 dashed, and these angles are pi, mind you, full pitch coil. This is pi electrical or 180 degree electrical. So, 2 dashed. In our case, they will carry same current, similarly 3 dashed. This is the armature slots. Got the point? Suppose only for 3, suppose the armature is having only 3 coils like this. If it is like this, then after this much length here once again 1, 2, 3 you will see, because you have developed diagram of the machine. Now, the question is what will be the MMF distribution? Consider one coil at a time. For example, 1 and 1 dashed, it will be like this. Suppose I will sketch it here, and against the space angle electrical this. During this to this 1 1 dashed, it will be, let me use a different color, so that so this will be the MMF distribution due to coil 1. Why I am telling like that? Forget about 2 3 and 2 dash 3, erase from your memory, only 1 and 1 dash is existing. If you consider at any point a flux path which will cross the air gap, above it there are north pole, south pole, etc. This is the thing. So, how much is the MMF enclosed by this path? If it is a multi-turn coil, Ni is the total MMF acting in the circuit, apply that circuital law of magnetism. This MMF will be dropped in the 2 air gaps, and Ni by 2 will be the MMF in each path. And this will, forget about 2 and 3 number of coils, they are suppose not there. So, it will be Ni by 2, and why I have assigned positive sign? Because this is cross, this is dot, lines of force will be in the vertical direction, assign positive sign. So, it will be Ni by 2, and then in this up what it will happen? Minus Ni by 2. Is it? Because 1 is here, once again dot. So, it will be directed downwards. So, for one coil I know, therefore, I will do the same thing for the second coil and third coil. So, this is for coil 1, then for coil 2 it will be like this, identical coils. Only thing is it will now exist between these 2 points, this and 2 dashed, it is there. So, it will be like this and so on. This is the developed diagram, mind you, of the circular thing, developed there. And similarly, for the third coil, it will be like this, which will be here, third coil starts here, cross same cross dot, continues up to this point here. This is also Ni by 2, this is also Ni by 2 and minus Ni by 2 and so on. Therefore, the resultant air gap. So, for individual coils I have found out separately. So, resultant field because of this sort of current distribution will be sum of these 3 waveforms. In this zone here in the middle, you see in this space all are additive, it will be 3 Ni by 2 in this zone. I did not intend to make a line like this. So, it will be like that. Then between this space 2 and 3, 1 Ni by 2, another positive, another negative. So, it will be minus Ni by 2 resultant, plus Ni by 2 plus Ni by 2 Ni, and then minus Ni by 2. So, Ni by 2 plus. So, in this way it will be. Therefore, it looks like if I draw it with a red curve, because space is not here, anyway I can draw it here, forget about this. So, resultant field form with a red line if I sketch, it will be, suppose you also remove this here, this dotted line. So, it will be somewhat, this is the axis, So, in this zone it will be 3 Ni by 2. So, MMF distribution will be somewhat like this. It will come in the middle. So, it will continue the maximum value up to this point and so on. And this side also it will be like this. It will be a stepped waveform, we know that. Got the point. Therefore, the resultant field waveform will be stepped and peak will occur here at the middle point of 3 and 1 dashed. Now, in case of DC machines, of course, there are coils all along, it is uniformly distributed almost. It is also uniformly distributed, not 3 coils only. We considered 1, 2, 3 and 1 dash, 2 dash, 3 dash for drawing that one middle, but there exists other coil also and same thing can be done. Therefore, for a DC machine, since the B distribution, the current distributions are like this, dot, 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 like that. These are all under south pole as we have drawn earlier, and then there will be perhaps a neutral coil, and then as many as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will be like this. These are the current. This and this one coil. This and the second of this is another coil, like that. Therefore, the peak value whatever will be, it will be here at the middle, depending upon number of turns and magnitude of the current. I can, earlier it was 2 Ni by 2 or 3 Ni by 2, something like that. So, it will be a waveform distribution of this form, which you can work out. Understood? This is the whole idea. Mind you, these here the brass axes are there in the, this is the armature coil, armature. This is the brass positions, which are 180 degree apart, brass. B1, B2, similarly here there will be one brush in the DC machine. It is consistent because the MMF resultant MMF will be along this line. How do I get it? This side cross, this side dot. So, right hand rule, thumb will indicate that direction. So, peak will lie here and it will be a stepped waveform. So, armature MMF distribution, armature MMF distribution is stepped and if there are number of coils, so that the distance between the two consecutive slots are very less, that is uniformly distributed coil, this can be broken up, this can be approximated as straight lines. Why not? Armature MMF, I can draw it like this. This is an approximation. So, in a DC machine we say that with large number of conductors you forget about this small variation and assume it to be triangular in nature. This is the peak value of the armature MMF M A. So, M A distribution along the air gap of the machine will be can be approximated to a triangular sort of waves function. We will continue with that, and mind you, this is your space angle theta. Therefore, I now have armature stator field as well as armature MMF, mind you, this is not flux, armature flux, and we will discuss in the next class how to superimpose the how to get the armature flux and then superimpose it with the main field flux to get the resultant field waveform. Thank you.